Hey, this is Mr. Janes. In this video, we're going to be going over the properties of quadrilaterals Tier 2 worksheet and how to complete it. Now, all these problems have to do with properties of quadrilaterals. So as you're doing this, please have your notes out so you can refer to the properties of rectangles, rhombuses, squares, parallelograms, trapezoids, isosceles trapezoids, and kites. In addition, a lot of these problems are more critical thinking oriented than just procedure. So don't just copy down the answers. Make sure you understand what's going on. If you don't understand what's going on by the end of this video, make sure that you ask a teacher or a friend to help explain or try the problem again. However, I will be going kind of quickly through some of the explanations, so if you need to pause or rewind to understand or hear things again, be sure to do that. So, let's start with number 1. In rectangle ABCD, AB equals x plus 1, BC equals 5y plus 3, CD is 11, and AD is 28. Find x and y. The first thing we should do with any problem is to label our sides. So here we have x plus 1, here we have 5y plus 3, here we have 11, and here we have 28. Now what do I know about a rectangle that will help me? Well, I know that any parallelogram, such as a rectangle, has congruent opposite sides. So x plus 1 is congruent or equal to 11, and 28 is equal to 5y plus 3. So we set up our equations. X plus 1 equals 11, and 28 equals 5y plus 3. If you solve these, you will get x equals 10, and 28, and y equals 5. On to question 2. Number 2, is QZRC a special parallelogram? If so, what kind? How do you know? Well, if we look at this parallelogram here, I will outline in blue. Okay, QZRC. What do we know about it? Well, there's nothing really marked here, so what might be useful is to write down what we do know. And we do know that this shape right here, this QTSR, is a rectangle. What do we know about rectangles? Well, we know a few things. We know that the opposite sides are parallel. We know that the opposite sides are congruent. We know that there are 4 90-degree angles. But most importantly, we know that these diagonals are congruent. So all 4 of these segments are congruent. Which means that if these two, this QC and CR, if those are congruent, and this is a parallelogram, well, we just remembered from the question before that the opposite sides are also congruent. So if QC has 1 tick mark, we can put 1 tick mark on ZR. And if CR has 1 mark, we could also put 1 on QZ, because remember, the opposite sides are congruent. And now when we look back on QZRC, we see that it's not just a parallelogram, but that all the sides are congruent. And so it makes it a rhombus. As for how we know, I'll just talk about this out loud, we know because since the diagonals of a rectangle are congruent, QC is congruent to CR, and since the opposite sides of a parallelogram are congruent, QZ and ZR are also congruent, and so all 4 sides are congruent. That makes it a rhombus. Question 3. If QC equals 2x plus 1 and TC equals 3x minus 1, find x. Well, again, we'll write these down. So you've got 2x plus 1 as this length right here, and we've got 3x minus 1 is that length right there, TC. And remember, from our last problem, we just talked about how the diagonals of a rectangle are congruent. So this length, 2c plus 1, will be congruent to this length, 3x minus 1. So we can write an equation, 2x plus 1 equals 3x minus 1. And if you solve this for x, you should get x equals 2. Problem 4. If the measure of angle TQC is 70, find the measure of angle QZR. So let's mark our diagram. Let's see, this is 70 right here. We have no other markings. Well, again, what do we know about a rectangle? Well, we know that all the diagonals of a rectangle are congruent. So let me just mark that right here. Okay. Which means that this triangle right here, this, let me get a highlighter, this triangle QTC is an isosceles triangle. In fact, all 4 of these triangles inside a rectangle are isosceles. So then we can do, with that information, is say, well, this is 70. This other base angle across from the congruent sides is 70. And 70 plus 70 minus 180 gives us this angle, 40. Okay. Next, we can get this angle right here. Because it is a linear pair, it is supplementary to 40. 40 minus 180 gives us 140. And lastly, we know that this shape right here, QZRC, is a parallelogram and that the opposite angles are congruent. So if C is 140, Z will also be 140. Now there are many ways to go about this. You don't have to do it the way that I did it. You could have found a whole bunch of different things. You could have remembered that rectangles have right angles, and so this right here would add up to 90, so this will have to be 20 degrees right there. Since this is a rhombus, that the angles bisect each other, and this is also 20. Again, this will be 20 because we've got a isosceles triangle, and that'll be 140. So you could have filled in a whole host of different numbers here, right? And I'll fill in some more of them here, 70, 20, 70, 20, 140. So any way you do this, right, you don't have to fill in all these numbers, but if you get some of these, they can help you get to the final destination of that angle up there, QZR. For number 5, if measure of RCS is 35, find the measure of RTS. So we know that right here, RCS is 35 degrees. And we're going to go and figure out what T is, right? RTS right there. Well, what can we do? Well, there's a few options. We could use the fact that this is an isosceles triangle to figure out what this angle is. Okay? And then maybe we could use the fact that this is a large right triangle. Okay, 90 degrees. We would know what this angle is up here. We could subtract from 180 to get that angle down there. That's one option. However, I'm going to prefer to do it slightly differently. I'm going to go ahead and subtract 35 180 to get this angle right here. So 35 minus 180 is 145. 145. And then, again, I know that this triangle down here is isosceles, so I can take 145, subtract it from 180 to get 35, and divide it by 2 for these two base angles, and know that this bottom angle is going to be 17.5 degrees. 17.5. Again, a whole bunch of ways you could have done that. Filled in all the angles you want, as long as you get down to that 17.5 using the properties that we've learned. 6. If the measure of QRT is equal to the measure of TRS, find the measure of TCQ. Well, what does that mean? QRT, that's this one right here, I'll put 2 tick marks on it, is equal to TRS, that's this one right here. Well, what's going on? They don't give any other numbers, so there's something, this has to mean something to me. And it does, right? In a rectangle, the diagonals do not bisect the angles. That means this line should not cut these angles in half. But the directions told me that they were equal, which means that this diagonal does cut these in half. When does that happen? What kind of shape does the diagonals bisect the angles? A rhombus does. And so this could be a rhombus, but it's also, because they said it in the directions before, it's also a rectangle. So how do we work with that? Well, if it's a rhombus and a rectangle, that must mean that this shape right here, QRST, is actually a square. If this is a rectangle and these angles are congruent, it must have congruent sides like a rhombus, so it must be a square. So this shape is no longer drawn to scale. And if that's the case, TCQ, this angle right here, is going to be a 90-degree angle, because in squares and in rhombuses, the diagonals are perpendicular, they form a 90-degree angle. Now this shape is not drawn to scale at all, but because of these because the diagonals bisect this angle, we can say this is like a rhombus or a square, and that the diagonals are also perpendicular. So 90 degrees it is. 7. RZ equals 6x. RZ equals 6x. ZQ is 3x plus 2y. And CS is 14 minus x. CS is 14 minus x. Find the values of x and y. Well, before, remember, if we go all the way back to question 2, we learned that all of these diagonals and some of these sides out there are congruent. So let me just mark that here. These are all congruent. And so we can set any two of these equations together. However, if we try and use 3x plus 2y, that has two variables with it. And we might have to end up using a system of equations or something a little more different. It'll be easier to set these two equations, 6x and 14 minus x, together because they only have one variable. So 6x equals 14 minus x, and if you solve that equation, you should be left with x equals 2. Now we can go back and write an equation like 3x plus 2y equals 6x because we know what x is and we can substitute it in. 3 times 2 plus 2y equals 6 times 2. Now, all you need to do is simplify and solve for y, and if you do that, you should get y equals 3. For questions 8, 9, 10, 11, we're going to use these four figures here. If you're doing this on your own paper, you may want to get a separate sheet of paper and draw this figure 4 times because there are 4 different questions, or just use a pencil and have an eraser handy. Here we go. Number 8. If measure of angle 1 is 30 degrees, what is measure of angle 2? So here's 30 degrees. Well, we've talked about this before. This is an isosceles triangle. We can take 30, subtract from 180, and divide by 2, and this will be 75. It's just like an isosceles triangle. Number 9. If 6 is 57 degrees, what is the measure of angle 4? Well, let's see. Angle 4, well, this is one big right triangle, remember, because rectangles have a 90-degree angle there. So remembering this adds up to 180. 180 minus 57 minus 90 will leave us with 33. Question 10. If measure of angle 8 is 133, what's the measure of angle 2? Well, I guess I could just find what angle 1 is here and then go for 2 because this is an isosceles triangle, just like we did in question 8. So 133 minus 180 is 47. And then subtract from 180, divide by 2, because this is an isosceles triangle again, will give us 66.5. For 11, if angle 5 equals 16, okay, 16, what's the measure of angle 3? Well, a few ways I could go about this, but the way I like to do it is remember that this is an isosceles triangle, so this is another base angle, also 16, and this whole angle here must add up to 90 because it's a rectangle. 16 minus 90 is 74, so that will be 74. And again, 10 is 66.5. 12 is tricky, so watch closely. ABCD is a rhombus. If the perimeter of ABCD is 68, so all around, and BD equals 16, so this whole thing is 16, find AC. Now, when we do this, first off, if we know the perimeter is 68 all around, and we know in a rhombus all the sides are congruent, right? We can divide that by 4 to get the length of each side. So 68 divided by 4 leaves us with 17. So it means that each side is 17 units long. Now, that doesn't really help us very much until you remember that a rhombus has a right angle right there. The diagonals are perpendicular. And what can we do with a right triangle? Well, we know this side is 17. We know this whole thing is 16, and these diagonals bisect each other, so this will be 8. So we've got a right triangle with 17 for the hypotenuse, 8 for this side. We can use Pythagorean theorem to find the length of this last side. So Pythagorean theorem, we'll call this x. So we'll say that x squared plus 8 squared equals 17 squared. And if you solve for x, you should get 15. So x is 15. However, remember, they wanted the length of AC, this whole length right here. Since the diagonals bisect each other, this length is 15. A to C is double that, or 30. Let's end on a high note with question 13. ABCD is a square. Find the measure of angle DBC right here. Since a square is a type of rectangle, we know that this is going to have a 90-degree angle right here, the right angle. Since the square is also kind of rhombus, we know that the diagonals bisect each other, or these two will be equal. So in a square, 90 degrees bisected, or divided by 2, leaves us with two 45-degree angles. So DBC is 45 degrees. That ends the front page of Properties of Quadrilaterals, Tier 2. Make sure that you're asking questions if you're confused, or rewinding the video if you need.